Okay, so at this point, you should be doing pretty well. You should be very comfortable with all of the rules so far. And now I'm just going to go over the final 4 rules, the rules that involve negations and contradictions. These can be confusing for people. So again, because these rules can be confusing, you want to make sure you're very confident doing proofs up until this point. So make sure that you feel good with the practice proofs that you're doing before you watch this part of the video. But now, if you're ready to talk about negation rules, we will talk about them. The first rule we need to learn is the rule that allows us to point out a contradiction. So, essentially, this rule is something that we use when we have 2 different lines of a proof that contradict each other. We use this symbol, this upside down T, to indicate that those 2 previous lines are a contradiction. Now, this rule, confusingly, this is called negation elimination. Why is it called that? There's no reason. It just happens to be called negation elimination. The name for it is difficult because you're not really eliminating any negation. What you're doing is pointing out that there's a contradiction in 2 different lines of your proof. You just want to remember that this one is called negation elimination. So what you're really doing is pointing out a contradiction. So negation elimination is the rule that allows you to write the contradiction symbol into your proofs. You use an upside down T to stand for a contradiction because a stand up T stands for true or tautology. So an upside down T is the opposite of that, which is a contradiction. So, okay, negation elimination cites 2 different lines. If we're using it in an actual proof, and these were lines 1 and 2, it would be negation elimination 1 and 2. Remember that you can't use this rule unless the 2 lines are an exact contradiction. So, for example, if you have this, and then that, you cannot use this negation elimination rule because these 2 lines, while they would lead to a contradiction, they're not an exact contradiction. So this is bad. Instead, you need just the 2 lines together. This is good. The 2 lines need to exactly match. They need to look exactly like each other, but with one of them negating the other. So, for example, you could have a more complicated thing. You could have one line like this and the next line like that, right? 2 lines that look exactly the same, but one negates the other. That didn't show up. Apologies. What I am trying to show is the instance where you have, for example, a line like this, and then a second line which is a negation of that exact same line. That would also be an instance of negation elimination. But again, you need the 2 different lines to look exactly the same, and one is a negation of the other in order to use this line. Okay, so now we're going to talk about negation introduction. So that was negation elimination. Now we're going to talk about negation introduction. Now, negation introduction is a strategy when your goal is a negation. You can only use this rule when you are trying to prove a negation. So, if I am in a situation where I want to prove not A, what I do is I use a strategy of a subproof. So I say, well, I'm going to assume the opposite is true. I'm going to assume that A is true. If A were to lead me to a contradiction somehow, that would mean not A must be true. So what I do is I assume the opposite of my goal. Prove that is a contradiction. So the goal must be true. So again, I get myself into a situation where I show that if A were a contradiction, then that only leaves one possibility, not A must be true. That's because in classical logic, every statement is either true or false. Remember, we talked about this in the beginning. These letters stand for sentences, and the definition of a sentence for us is something that has a definite truth value. It's either true or false. So, in other words, we affirm what we call the law of excluded middle. There's nothing between true or false. There's no other option. So if I could prove that A is a contradiction, not A, then must be true. So what I do is I look at my goal here, and I use this strategy. I assume the opposite of what I actually want to prove. I assume the opposite of my goal. If that thing is a contradiction, then the goal must be true. So again, I use negation introduction when my goal is a negation. I can only use this rule when I am trying to prove a negation. In all other cases, I can use a similar rule, but it's not this one. It's indirect proof, which I'm going to talk about in a second. But negation introduction, I can only use it when my goal is a negation. So I'm trying to prove a negation. I assume the sentence without the negation. I assume the opposite of the sentence. If that leads me to a contradiction, then I know the goal must be true. So, as I said before, a very similar rule is indirect proof. So again, indirect proof is just the opposite of that, but it's essentially when you are trying to prove a statement where it's not a negation, say, you again assume the opposite, but in this case, you assume not A. If you can prove that's a contradiction, then you know A must be true by indirect proof. In both cases, indirect proof and negation introduction, you cite the subproof. So you want to cite the entire subproof, whatever those lines are. So again, negation introduction and indirect proof are very similar, but negation introduction is when the goal is a negation, and indirect proof is when the goal is not a negation. So the idea is, again, I assume the opposite of the goal. If not A would lead to a contradiction, then that only leaves one possibility. A must be true. That's how I show that A is true. So at this point, you may want to pause and do some more of the practice problems here before you listen to the final piece of this. The final rule is explosion. We designate it with an X. So the idea of explosion is that if there is a contradiction in the proof, anything would follow from that. Remember that when you have an argument with contradictory premises, it's automatically valid. So that shows that anything would follow from a contradiction. So if you have a contradiction appearing in your proof, you can write any sentence you want by explosion. So let's see how we might use this in practice. Here is an example. Let's say we have premises like this. And we want to prove that A is true. Now, I'm going to use a strategy of disjunction elimination to begin with, because this premise is a disjunction. So I'm going to take my first possibility of A, and I'm going to prove easily that A is true based on A, reiteration of line 3. Then I need to explore the second possibility of B. Now, in this case, this is a problem because you see you have a premise here, not B, and then you also have this thing, B. So first you use negation elimination. You point out the contradiction. So negation elimination by lines 2 and 5. So first you write the contradiction symbol and point out that contradiction. Then the next thing, though, is you remember you're trying to prove that A is true, so you need to finish the subproof with A. Well, luckily, the explosion rule says that from a contradiction, anything will follow. So you just write whatever you're trying to prove. In this case, it's A. A by explosion on line 6. And you just cite one line. You cite the line that has the contradiction on it. Then I've completed my proof here. So I cite the disjunction, the first subproof, and the second subproof. But see how I used the explosion rule in there? When I saw a contradiction appear, I was able to write whatever it was I was planning to prove anyway. So I use the explosion rule when I find a contradiction. I should get excited because that means I can immediately write whatever I want to prove. All right, so at this point again, you should pause and do more practice problems. If at the end of this video you still have trouble, we should make an individual appointment, or you should go through the video again and do the practice problems. But hopefully this has helped review our rules.